Welcome back to part 2 of section 612. We're still talking about inverses. So we're going to sketch the inverse. Now the easiest way to sketch the inverse of this is to make a table of the points that we already have. So for our graph, it's a function, so we can say f of x. So here we have our values, x and y. So we have our values for x. We have a -4, -2. We've got a -3, 1. We've got a -2, 2. And we've got a -1, 1. So for our inverse, f inverse of x, we have x and y. I don't like that I use that inverse notation, and I'll talk about why I don't like that I use that inverse notation. So switch the x and the y's. -2, -4. 1, -3, 2, -2, 1, -1. So we plot those points. We're at -2, -4, 1, -3, 2, -2, 1, -1. So our points look like that. So there's the graph of the inverse. Now, the reason I don't like the inverse notation there is when we look, the original one failed the horizontal line test. And now when we actually sketch the inverse, it fails that vertical line test. So we can see in a couple different ways that the inverse is not a function. It fails the horizontal line test looking at the original, and it fails the vertical line test looking at the graph itself of the inverse. Now the line of symmetry is that line y equals x. If you were to fold along that line y equals x, the graphs would match up. So we're going to find the inverse of y equals -2x plus 6. So for y equals -2x plus 6, the slope is -2 and the y-intercept is at 0, 6. Over 0, up 6, and the slope is -2. Go down 2 over 1 in both directions. Here is our graph. Now, for the inverse, switch the x and the y. So x equals -2y plus 6. Subtract 6 from both sides. X minus 6 equals -2y. And divide each term by -2. -1/2 x plus 3 equals y, or y equals -1/2 x plus 3. So the slope is -1/2, and the y-intercept is at 0, 3. 0, 3, up 1 over 2, up 1 over 2. I'm going to use a different color for this one, purple. And here is the graph of the inverse. Oh, excuse me. That should have been a -1/2. What happened? Sorry. -1/2 x plus 3. So our y-intercept is at 3, but we're going down 1 over 2. There is our inverse. There's y equals -1/2 x plus 3. And they're reflections of each other along this line, y equals x. If you fold along that line y equals x, they're going to match up to each other. The inverse is a function as well. for the original, it passes the horizontal line test, and for the inverse itself, it passes that vertical line test. All right, let's go to the next page, please. So for problem number 7, find the inverse. So we can graph the original function first. Y equals x plus 2 squared minus 6. So now we're at our vertex is at -2, -6, and a is 1. Because a is 1, we can just go up 1 and over 1 in both directions. You go up 3 over 1, up 3 over 1. And then from there you can go up 5 over 1. And then you can go up 7 and over 1 in both directions. So here is, the graph. So looking at that, already we can tell that the inverse is not a function. It's going to fail that horizontal line test. Now let's find that inverse algebraically. So we have y equals x plus 2 squared minus 6. So x equals the quantity of y plus 2 squared minus 6. Add 6 to both sides. X plus 6 equals the quantity of y plus 2 squared. And then we take the square root of both sides. So we get that plus or minus the square root of x plus 6 equals y plus 2. Subtract 2 from both sides, so y equals plus or minus the square root of x plus 6 minus 2. So we plot those points. We're at -6, -2, and here's our points. Didn't go far enough, sorry. And that would be good enough. There is our inverse. And you can see it fails that vertical line test. If you did want to see that line of symmetry for the two, it's still going to be at y equals x. It's always going to be at y equals x. That's the line of symmetry for the inverses. And just take a note that the inverse is not a function. So now, the last one, problem number 8. Here we have, there's actually 2 more. For the inverse, f of x equals x squared plus 3. Now, if we were to graph it, f of x equals x squared plus 3. Our graph would look like this. That's f of x. Now, because of that, it wouldn't be a function. So what we're doing is we're restricting our domain to x is greater than or equal to 0. So really what our graph is going to look like is this. We're restricting it to one side of the parabola, making the inverse a function, because now it passes that horizontal line test. Now we can have our inverse being a function. So to find that, we're going to replace f of x with y. So y equals x squared plus 3. Subtract 3 from both sides. Y minus 3 equals x squared, and then take the square root of both sides. So x equals, I forgot to switch them. Got ahead of myself. So x equals y squared plus 3. Then you subtract 3. X minus 3 equals y squared. take the square root of both sides, so y equals plus or minus the square root of x minus 3. Now, because we restricted our domain, our inputs, to x is greater than or equal to 0, when we do this, we're going to use the positive only. So f inverse of x equals the positive square root, so just the square root of x minus 3. And that would be a function. And our inverse would look like this. And you can see that graph that I drew in black would pass that vertical line test. And they are reflections of each other along the line y equals x. Last problem, number 9, find the inverse. So y equals 3x cubed minus 2. So x equals 3y cubed minus 2. Add 2 to both sides. X plus 2 equals 3y cubed. Divide both sides by 3. X plus 2 over 3 equals y cubed. And then take the cube root of both sides. So y equals the cube root of x plus 2 over 3. So we write this in function notation. F inverse of x equals the cube root of x plus 2 over 3. And there's our function. Okay, that does it for inverses and functions. I will see you again in the next chapter. Thank you.